During our last video, we discussed one sample t-test. This helped us whether the particular question or variable is near the mean or away from the mean. Say, if we have got the probability of happening 95%, that is 95% confidence interval, it is near the mean, it is within the mean. So we see that with one sample t-test, whether the audience respondents, they are near the mean or away from the mean, expected mean. Today we will discuss the two samples, two independent samples, whether there is any difference between the two independent samples or they are same. The system simply finds the combined standard error and then it finds out whether there is any difference or there is no difference. This can be done with easy command, very easy command. I have started Jupyter editor, and in that I'm just going to write down one simple command, that is stats dot t test underscore independent ind x comma y, where x is going to be our variable one group and y will be another. Now we cannot get x and y. We will have to create x and y, or we will have to upload the file. So in our last video, we have learned import tkinter as tk, pandas as pd, import maths, import seaborn as sns, import matplotlib plot as plt, scipy, import stats, tkinter. We will import everything from tkinter. We create a window, and in that window the file is read, and then after that, after reading the file, this window is closed. Then dfpd read excel, pd pandas will read the file which we have created here as fp, and then the columns are counted, and then the columns are numbered, and we say which columns we want to compare it. This is what we did it last time. So I'm just going to copy everything from here. I'm just going to copy everything from here and just going to paste it above. So my simple thing is this one. Now here B will be our choice for the second sample. Choice for first sample. A is our choice for first sample, which will be first sample, and this B will be choice for second sample. Your choice for second sample. Okay, so, and then columns. X is columns, integer a minus 1, and y will be our columns. Y will be our columns, integer b minus 1, because indexing starts with the 0. And now stats t-test independent. Now this will be your df dfx and dfy. But we will have to now do some refinement, something which should look nice. So we will say print the test statistics for samples, comma, we will close it, say comma x, and comma y, comma this stats t-test. So this will be, now this is beautification of your problem. Let us run it. It will first import all the packages. After that, it will open a window. We will select the file which I have just shown you, that is test 8. It has opened the box where we are going to select our file test 8. Now it is asking me whether serial number 1, serial number UDB. We want the comparison between class B and this. First we will say 3 and then we will say 2 if there is any difference between the two. Whole, complete. Now it says test statistics for sample class test B and class test A. T-test independent results are statistics 1.95 and p-value is 0.056. It means this 0.056, it is more than 0.056. So we can say there is no difference. There is no difference between the two. Now these are so many decimals. There are so many decimals, but we want to make it clean. Up to 3 decimals. It looks nice up to 3 decimals. So what I will say, I will tell that stats here, that statistics should be with 3 decimal and p-value should be with 3 decimal. So I am going to write it here as comma statistics static is equal to percentage 6. I want 6 and up to say 3 decimals. 3 F, and similarly I want p-value should also be percent 6.3 F, and then I will say percent. I have written T statistics in commas. T statistics is equal to percentage 3% 6.3 F, p value is percent 6.3 F, commas. Now I close and I write percent stats t-test independent tag dfy and dfx. I can make it dfx or dfy, whatever. The first one will come minus second one, whatever you put it. Let us run it again. I will select the test 8 and I'll say my 3 and 2, and now see the decimals are coming. It is negative now, minus 1.9, minus 1.950 t statistics, and p value is 0.056. So up to 3 decimals. So our main command here is only stats.ts underscore independence. The benefit of this working with this is you can change many things. You can add histograms, you can add pie chart, you can add bar chart, you can do many things. But actual, these are the common things which we are using everywhere, that we are to read the file, then we have to decide which columns we want, and that it will convert the columns, and this will be done. Let us say now run again test 8, and then we can say our number 2 is first, number 3 is second. So we will say t stat is 1.950, p value is 0.56. Mean there is no difference between A and B. There is no difference in A and B. Let us say make few changes here and there. Let us say few changes here and there. I am going to make it now 45 here. I am going to make it 45 here. I am going to make it 57 here. Let us see if there is any change in the result. Any change in the results. I'll say run. I will pick it up now, test 8. And I will say now by 3 and 2. So this is now the difference is minus 2.031, and now the p value is 0.18. It may be a difference. There is a difference because p value is less than 0.05. Thanks for watching. In our next video, we will talk about paired t-test, one-to-one comparison, where there is a one variable is dependent on the other. We will use the same file test 8 and we will work on. Thanks. You may submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments for your work. Thank you.